It put the bang in the Big Bang. Then you get Big Bang.
Because the Big Bang happened in an instant of time, there could actually be a universe before the beginning of our universe.
Every time you gaze up at the vast expanse of the night sky, doesn't it make you feel incredibly small and yet so connected to the vast cosmos? Every star, every planet, and even our own Earth have stories behind them. Stories that folks have been trying to figure out for a really long time. When we look up, we're basically looking at a giant puzzle, asking the big question, where did it all start? So, how did the vastness that surrounds us come into existence? Was it a divine hand that painted the canvas of the cosmos? Was it a gradual, ever-evolving process that led to the formation of galaxies, stars, and planets? Enter Dr. Michio Kaku, a theoretical physicist and one of the modern-day torchbearers of the quest to understand the universe's origins. In his recent work, Kaku challenges the widely accepted Big Bang theory, suggesting that perhaps our universe's inception isn't as straightforward as we once thought. He proposes something even more mind-boggling and mysterious. You want to find out? Then stay with us. By the end of this video, you might just view the universe in a whole new light. Although no theory for the origin of man, time, and the universe is generally accepted, there are three theories that stand out: the creation theory, the evolution theory by Charles Darwin, and the Big Bang theory. The creation theory, coming from many religious stories, suggests that everything in the universe, including our planet and every living thing, was made by a powerful being or force. Many cultures around the world have their own stories about this. For example, in the Bible, it's said that God made the world in 6 days and made people from dust. Other cultures, like the ancient Egyptians or the Norse, also have stories about gods or powerful figures shaping the world and life. These stories give people a feeling that there's a reason for everything, and that the universe was made with a plan. On the other hand, Charles Darwin came up with a different idea in the 1800s. He studied nature and wrote a famous book called On the Origin of Species. He believed that all the different kinds of animals and plants we see today came from older forms of life. Over a very long time, these living things changed bit by bit. The ones with helpful changes were more likely to survive and have babies. This is what he called natural selection. So, over time, a kind of animal could change so much that it becomes a whole new type. Darwin's idea made a lot of people see nature in a new way. Instead of everything being made all at once, he showed that life has been changing and adapting for ages. Of the three, the Big Bang theory is the most accepted. The theory is widely accepted in the realm of science and cosmology since it is supported by a wide range of evidence. But what exactly does the Big Bang mean? Simply put, the Big Bang theory is an idea that the universe began as a single point and later on expanded and became inflated to what it is at the moment, and it is still expanding. In other words, all the matter that existed at that time was compacted into a small ball with infinite density and intense heat called a singularity. According to the theory, it is this ball that continues expanding to create our universe as we know it. All this happened roughly 13.8 billion years ago. Just like many other theories in physics, the Big Bang theory is based on two major assumptions. To begin with is Albert Einstein's general theory of relativity that accurately describes the interaction of all matter.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing.
The second assumption is the cosmological principle that states that the observer's view of the universe does not depend on the direction in which he looks, nor his location. This means that the universe looks the same in all directions and at all points. Coupled with these assumptions, Michio Kaku discredited the Big Bang theory because it does not explain about the dark matter and dark energy that makes up 95% of the universe. Dark matter, unlike regular matter, doesn't emit, absorb, or reflect light. It doesn't interact with electromagnetic forces, which means it doesn't produce or respond to light. But its gravity affects the motion of galaxies, and its presence is inferred from the gravitational effect it has on visible matter. Scientists know far less about dark energy, but believe it's responsible for the accelerated expansion of the universe. These two phenomena, making up the majority of our universe's mass energy content, challenge our understanding at a fundamental level. Besides, the theory does not explain what happened before the Big Bang or where the energy that was used in the Big Bang came from. Big Bang tries to describe the early universe, but it does not explain why there is a universe to describe in the first place. After discrediting the Big Bang theory, the 76-year-old Michio Kaku embraced the string theory, which he believes solves the mystery around the origin of the universe. The professor of theoretical physics argues that string theory is a more fundamental theory that explains everything that the Big Bang theory can explain and much more. The beauty of string theory is that it can be used to explain all the laws of physics. Under this theory, the fundamental parts of the universe are not point particles, but rather one-dimensional objects that are known as strings, which vibrate in different ways. A good example: an electron will vibrate in a different way, while a photon will vibrate in another way. Let us simplify this. The main idea in string theory is that all things in the universe, such as particles of matter or light, are made up of vibrating strings. Professor Kaku believes that the strings are billions of times smaller than a single proton. He argues that the strings vibrate billions of times per second in 10 dimensions of space. Why would a renowned physicist like Michio Kaku believe that this is how the universe operates? To understand this, we need to go back like 100 years. By the end of the 1800s, physics was riding high. Scientists were confident that they had thoroughly understood concepts such as electricity, heat, magnetism, gases, and gravity. Some, like British mathematical physicist Lord Kelvin, was so confident that he concluded saying, "There is nothing new to be discovered in physics now. All that remains is more and more precise measurement." Little did Lord Kelvin know that his confidence in scientific research was just but a mirage. Sooner than later, the new crop of scientists such as Einstein, Bohr, Planck, and Heisenberg came up with strange physical theories that completely revolutionized the scientific world. And one of these theories is the string theory, that greatly improves our understanding on the origin of the universe. After years of extensive research, scientists arrived at 5 variations of string theory. In 1955, physicist Edward Witten unified all the 5 variations of string theory into a single concept known as the M-theory. It is important to understand that M-theory is not a replacement, but an extension of string theory. Let us forget about the theories for a moment. There is some good news. Thanks to NASA's James Webb Space Telescope, we can now peer into the distant past by looking at the images of this giant space observatory. The beauty of the Webb telescope is that it helps us understand the facts as they are. Science and technology often advance hand in hand. As our theories grow more sophisticated, so do our tools to test them. Telescopes like the James Webb allow us to look back in time, to glimpse moments close to the birth of the universe, providing essential clues to the validity and tweaks needed in our prevailing theories. The role of the $10 billion telescope is explained on NASA's website, and it reads, "The James Webb Space Telescope is a giant leap forward in our quest to understand the universe and our origins. Webb will examine every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of galaxies, stars, and planets, to the evolution of our own solar system." At this point, you may ask yourself, how can this telescope see back in time? Here is the answer. The powerful telescope has an infrared vision that helps it peer back over 13.5 billion light years, which is the furthest that we have seen into space. Here we can see how the first stars and galaxies formed out of the darkness of the early universe. This can be confirmed by the latest image of the galactic cluster, which contains thousands of galaxies. From the images from the James Webb Space Telescope, the prediction that the Big Bang would create an abundance of helium was off by a factor of 2, and the prediction that the Big Bang would create an abundance of lithium was off by a factor of 20. In addition to the absence of the larger, more distant optical illusion, there is also the existence of large-scale structures that are too big to have formed in the time since the Big Bang. According to researchers, all of these are examples of things defying current scientific understanding. The Big Bang Theory makes 16 incorrect predictions and only one correct prediction, which is the abundance of deuterium, an isotope of hydrogen. This and more significant inconsistencies have made even the most senior officers at NASA doubt the opinions they have held for decades. In the meantime, however, Astronomers are making great strides toward expanding their knowledge of the early universe, thanks to the incredible data coming down from James Webb Space Telescope. As much as the images given by this telescope insinuate that the Big Bang is false, some scientists have understood otherwise. They say that the discovery that galaxies in the early universe are more plentiful and a little more massive and structured than expected does not indicate that the Big Bang theory is incorrect, but rather the cosmology that came after the Big Bang adjusted a few details here and there. And this is where the excitement of science lies. Despite the claims made by science skeptics, scientific inquiry is never black and white. Each day we perpetually expand our knowledge and refine our hypotheses. Observation and evidence are the two most important pillars of the scientific method. We cannot wait to have more. More than 1 year into its mission, the James Webb Space Telescope sent very impressive pictures unraveling some of the cosmos secrets never yet discerned by the human eye. Did it discern new life out there? Just not yet, but it's in the process. We can be sure that the results will be clear, extensive, and convincing beyond any reasonable doubt. Most importantly, scientists believe that the James Webb Space Telescope will live up to its objective of unraveling our origin and how the universe came to be. What is your take on the Big Bang theory? Feel free to share your views in the comment section below.